Question 18. Solve the following equation for x. So the first thing I would do is get rid of the fraction. So e to the x plus 9 equals 2e to the minus x plus 10. And then I take everything over to the same side. So 2e to the minus x plus 1 minus e to the x equals 0. Then I would times everything by e to the x to get rid of the minus e to the x. I get 2 plus e to the x, minus e to the 2x. And you should see that this is basically a quadratic equation in e to the x. So I'd let y equals e to the x, just to make things look a bit clearer and familiar. So 2 plus y minus y squared. And then you should see that this will sort of factorize, and we need two numbers that times together to make 2 and add together to make 1, so that will be 2 and 1. Apologies, got those the wrong way around. So hopefully that's clear. So then y equals 2 or minus 1, so therefore e to the x equals 2 or minus 1. So for e to the x equals 2, we get x equals log 2. And for e to the x equals minus 1, we don't have any real solutions. So at this point, you probably could finish. I'm not entirely sure if the PAT expects you to know imaginary numbers and complex numbers and things like this, but just if you're interested, there are solutions that are not real for e to the x equals minus 1. So if you've ever done complex numbers before, you should know you can represent them on an Argand diagram, sort of like this, where z, our complex number, would be represented as e to the I theta. So in this case, theta equals 0 would give 1, theta equals pi over 2 would give I, z equals I, etc. So if we want e to the I theta equals minus 1, then what would theta equal? Well, theta would equal pi. But remembering you can sort of go around as many times as you want, theta would equal pi plus some integer number of lots of 2 pi's, because you can go around as many times as you want, you still keep getting back to minus 1. So therefore, e to the I pi plus n some integer 2 pi equals minus 1. Therefore, in our case, where we have e to the x equals minus 1, x would equal I pi plus n 2 pi, where n equals 0, 1, 2, 3, etc. Again, I don't know if they would actually expect you to get this solution. I feel like for 3 marks that would be a big ask. You're probably fine with just this one. But you know, if you're interested, there's the other solution.